Okay, so good day, everyone. In the previous video, we have discussed about the precedence of logical operators. Okay, so in other words, given a complicated expression, and there are multiple symbols as well as variables. So which variable, how are we going to evaluate that complicated expression? Okay, the topic for today's video, on the other hand, is determining the truth value of those complicated compound propositions. Okay, to do that, we are going to use truth tables. And what we are going to do is use a separate column to find the truth value of each compound expression that occurs in the compound proposition as it is built up. So let's have an example. So suppose we have this compound statement, the conjunction of P implies Q and Q implies P. Okay, so as you can see, this Q implies P is just the converse of this implication. Before that, one technique that you can do is to look at the variables that are present in the compound statement. So we have P and Q. So let's try to determine first the combination of the truth values for these two variables. So if P is true, then the Q, P is true, the Q could either be true or false. Okay. And if P is false, then Q could either be also true or false. So in short, P and Q could either be true and true, true or false, false or true, lastly, false or false. Now, let's evaluate the P implies Q. So if you look at this compound expression first, so you look at the group na statement. So for instance, this P implies Q is group, meaning this will take a higher precedence over this conjunction first. So you do not evaluate this one, Q and Q. So you evaluate the group na expressions. Okay, so let us try to determine the implication of P and Q. So we know that for a certain conditional statement, it will only be false if the hypothesis is true and if the conclusion is false, and this will result to false. Otherwise, it is true. Okay, so what we are going to do is fill up this column and find that row where the hypothesis is true and the conclusion is false. So this row is false. Okay, sorry. And the rest of the row will be true. Okay, so if you remember from our previous lessons, an implication will be true if both P and Q are true, and if P is false, regardless of the value of Q. Okay, so now let's proceed to another expression or statement. Q implies P. Okay, so the Q implies P is just a converse of P implies Q. All right, so now since Q is the hypothesis and P is the conclusion, we will look for that value, the truth values that will make this false. So this will only be false if Q or the hypothesis is true, as well as the conclusion or P, which will be false. So in this case, it's this row. So this will result to false. And the rest will be true. Okay. Now, now that we have figured this out, the P implies Q and the Q implies P, we are now going to combine these two expressions. And as we can see, it is combined using a logical operator and, or In other words, we are taking the conjunction of these two implications, okay? So we have P implies Q and Q implies P. Let's start from the first row. If P implies Q is true and Q implies P is also true, taking the conjunction, this will result to true, okay? Because as you remember, the conjunction will only be true if both of your propositions are true, okay? And what if P implies Q is false and Q implies P is true? So this will result to false because we have a false state, false truth value. Okay, so we have the third row. P implies Q is true and Q implies P is false. So since Q implies P is false, then this will result to false. Okay, and lastly, P implies Q is true and Q implies P is also true. So since both statements are true, then this conjunction will be evaluated as true. Okay,